Good morning, friends. It gives me immense pleasure to be here again for my course, Flight Mechanics. I am in the process of discussing about definition and the terminology which are used for the flight mechanics. As on today, I will be taking the first module, that is definition and the terminology of introduction to airplane performance. And in this, we have already discussed about aircraft performance. So in this, we have already discussed about aircraft introduction to aircraft performance, and today we are going to take about some definitions and terminology related to the aircraft performance. And you know, I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. Today I am going to take the topics like definition and terminology. In this, few topics like aerodynamic forces, lift and drag, I will be discussing. Drag polar, I will be discussing. Stall velocity, standard atmosphere, and so on, I will be discussing in today's lecture. So, definition and the terminology of introduction to aircraft performance, module 1, I am going to take. So, in this, I will see the definition aircraft performance. So, if you see what is the performance, so in this, we have the different missions of the aircraft. If this is the aircraft, and if aircraft is, first one is take off, on the ground it will run, then it will roll up, then it will climb. After climb, it will go to the cruise. After cruising, it will descend, and then it will loiter if it is required. It is called the loiter, and then again it will descend, and then it will land on the runway. So these are the phases of the flight, and we have to discuss these all the phases during this course that is called aircraft performance or the flight mechanics. So here, an airplane performance can be defined as the capability of an airplane to operate effectively while serving a specific purpose. Among the elements of performance are takeoff and the landing, distance, rate of climb, ceiling, speed, payload, and the fuel economy. These are the points which we will be discussing in this aircraft performance or the flight mechanics course. Now we will see the wing loading. So if you see this aircraft from here to here, it is from wingtip to another wingtip, it is called the span, and from leading edge to the trailing edge, it is called the chord. If you see from the top, the area which is visible from the top, it is called the wing area, and how much lift this wing is generating, it is called the lift produced, or this is also equal to the weight of the aircraft. So if we talk about the wing loading, so this wing loading is equal to W by S or L by S. So this is called the wing loading, very important parameter for the aircraft design. So the lift produced by the wing per area is called the wing loading. So here it is the area, S is the area, and L is the lift. So lift produced per unit area, it is called the wing loading. If it is the cruising, so L is equal to W. So we can also write this is wing loading is equal to W by S. So this is the, now we will discuss about drag polar. So if you see, the drag is a force which is trying to oppose the motion of the aircraft, and drag polar is the relation between the total drag and the different types of the drag. So if CD is the total drag, so it is CD naught is the parasitic drag, and then KCL square. So this CL is a lift coefficient and CD naught is a drag coefficient, and K is a parameter which is defined as a 1 by pi E and aspect ratio, where aspect ratio is equal to AR is equal to B square by S, where B is a span of wing and S is a area of wing. So E is a Oswald efficiency, which is equal to 1 or less than 1. So here we will get this K. CL is a coefficient of lift. So in this way we can, this equation is called the drag polar equation. So the drag polar is the relationship between the lift here, lift on an aircraft and its drag. So here lift is here this parasitic drag is there, expressed in terms of the dependence of the drag coefficient on the lift coefficient. So it is a relation between, so if you see, it is, if you increase the lift, drag will also increase. So it will be looking like this is the parabolic condition. So this is the drag polar, CL and the CT. So now we will go for the next definition. Define a stall angle. And you know what is the stall? If suppose this is your aerofoil and this is the free stream velocity and it is moving like this, the below is moving like this, there is no separation. But as you increase this angle of attack, now angle of attack is more, and it is, so it will go like this, and after some time your flow separation will take place. This is the separated flow here. Here the vertex are formed. So in this case there is an angle, that angle is called the stall angle. If I draw here alpha, this is the angle of attack and this is the coefficient of lift. For the symmetrical wing it will be like this, and this is called CL max. So, and this is called the stall angle, alpha stall. So the angle at which coefficient of lift is maximum is called the stall angle. So here we will be discussing here that the angle at which maximum lift coefficient, that is the CL max, is produced. Another is define the flow separation. So you can see here just I will put the different colors. So if you see here, this area is a separated flow area and here this vertex are formed. So here we have the kinetic energy here. This kinetic energy, as it is going due to the boundary layers, the energy of this is reduced, and here the pressure energy, that is called the adverse pressure, it is pushing, and this is the separation point. So at this point your flow will not be attached and it will move towards the upward, and this area will be useless. So wing, this area is not producing the lift, however this has started producing more drag. So we can define the, now all solid objects traveling through a fluid requires a boundary layer. Just now I have discussed what is the boundary layer. The layer at which the speed is not the same. So if this is the flat plate, flow is coming from here and after some time it will go. So if it is the 10 meter per second, due to this friction here the speed will be very less. At the surface it is 0, V is equal to 0, and here it is V is equal to 0.99 of the actual V. So this is called the boundary layer thickness, and this is happening due, and this flow separation, it is adverse pressure is acting here. So all solid objects traveling through a fluid acquire a boundary layer of fluid around them, where viscous forces occur in the layer of fluid close to the solid surface, and it is happening due to the viscous effect. So here the viscous effect is there, this is called the viscous effect, and this viscous effect is playing the role for this flow separation. Now the define L by D ratio. So here this L by D is a aircraft performance parameter. Very important parameter, and whatever this in the flight mechanics, in all the performance, L by D we take, and it is very, very important characteristics. It is ratio of lift to drag. This gives about the efficiency of the aerodynamic object put in the airflow. So how much is L by D? That much is wing is efficient. Define stall speed. So we know that stall speed, it is the minimum speed at which aircraft will sustain in the air. So it is very important that our aircraft should not go below this speed. Always we maintain minimum 10% above the Vs. So actual V takeoff should be 1.1 Vs. V touchdown is equal to 1.15 of Vs. So V approach is equal to 1.3 of Vs. So if you see here, all these velocities are described with respect to the Vs. So what is the Vs? So Vs is the speed at which you have the maximum coefficient of lift. So if I see lift is equal to weight is equal to half rho V square S CL max. So if CL is a maximum, this speed is Vs. So this Vs is equal to 2 W by S under root whole divided by rho into CL max. So at the speed at which you have the maximum coefficient of lift, and we have seen that maximum coefficient of lift will be at the stall angle, that is called alpha stall. That is why it is known as a V stall. And this is the CL, and this is the alpha, and this is the CL max. So we can define this our velocity, that is the stall speed, and we can say that it is the minimum speed at which aircraft will be sustained in the air. If your speed is less than this, aircraft will not be able to fly, and this is the one of the safety margin of the aircraft. So stall speed or the minimum steady flight speed for which the aircraft is still controllable. So if the aircraft is flying, there is a minimum speed in which aircraft is at the cruise with a fully controlled condition. Now another stall speed, that is called VSO. Stall speed or a minimum flight speed in landing configuration. So I have just now told that this VSO is equal to 1.15 of Vs. So this is the landing. During the landing, your aircraft should not be less than 1.15 Vs or 15% higher than the Vs. So now define VS1. So stall speed or a minimum steady flight speed for which the aircraft is still controllable in a specific configuration. So in fact, this stall speed is a minimum speed. It is a danger zone. We should not go. But in the real case, we should not go less than VS1, where VS1 is minimum 10% higher than the Vs. But in this speed, your aircraft should be able to sustain, able to control without any problem. Define standard atmosphere. So we know that standard atmosphere, we have some pressure, we have some temperature, and we have some density, and the pressure is 1.2 to 1, it is 1.01 bar to 73.5 288.6 and rho is 1.225 kg per meter cube. So this is the standard temperature and the pressure. So we will define it. Standard atmosphere unit of pressure equal to the mean atmospheric pressure at sea level. It corresponds to the pressure exerted by a vertical column of a mercury as in the barometer, that is 760 millimeter or 29.9213 inches high. So it is for only pressure, it is defined here. If you see here, define the troposphere. So it is the first layer of the aircraft, of the atmosphere, where we get sufficient amount of oxygen, sufficient amount of air. It has got some height. This height is dependent upon the earth. If you are at the pole, this height is less. If you are at the middle of this earth, this height is more. So we will be defining this. Here is the troposphere. In this you have the cloud, you have all the water, this all things are there in the atmosphere. So the troposphere is between 5 and 9 miles. It is 8 and 14 kilometers thick, depending on where you are on the earth. It thinnest at the north and the south pole is 8 kilometers nearly. This layer has the air where we breathe and the cloud in the sky. The air is densest in this lower layer. So in this lower layer, if you see, this is the sea level. As you go up and up, your density rho is here high and here is low. Here you have the air to breathe. This height is dependent upon the earth. If it is, these are the two poles. So from here it is 8 kilometer from here, but if you are here, it is 14 kilometer. Average we take 11 kilometer. Average height is 11 kilometer. So this is the explanation for the troposphere. What is the main function of the troposphere? So why it is so much necessary, the troposphere? The troposphere provides oxygen that we can breathe, keeps earth at a livable temperature and allows for weather to occur, making it a very important part of the atmosphere. How thick is the troposphere? How much the actual height of the troposphere? So the troposphere begins at the earth's surface and extends from 4 to 12 miles, that is 6 to 20 kilometer high. Which layer is free from the cloud? So next layer after the troposphere is another layer which is called the stratosphere, and this stratosphere is defined. The stratosphere is a layer on the earth atmosphere. It is the second layer of the atmosphere. We move upward. The stratosphere is very dry because air in this layer contains little vapor, water vapor. Because of this, stratosphere is free from cloud. So if you are flying in the stratosphere, you won't get any cloud. Free of the cloud, there is no danger for the cloud. You won't get any lightning and all, because due to the cloud only lightnings are happening. So if you are flying above this troposphere, it is called stratosphere. It is better to fly. However, the density of the air is reduced, so the efficiency of the engine and the lift producing capacity of the aircraft will also be reduced as the density of the atmosphere is reduced. Now define the airfoil lift. So how the lift is produced? Lift is a force which is acting. Lift is a force that directly opposes the weight of an airplane and holds the airplane in the air. Lift is generated by every part of the airplane, but most of the lift on a normal airline is generated by the wing. Another definition: lift is a mechanical aerodynamic force produced by the motion of the airplane through the air. So here I will discuss how the lift is produced and how it is done. So this is the airfoil, and this is your velocity of the wind. This will go like this. Here also it will go like this. So if you see here, the upper surface, due to the curvature, it is taking more distance and comparing to the lower surface. So upper surface velocity is high, pressure is low. In the below surface, velocity is low, pressure is high. Net pressure will act upward. This is the total pressure. This pressure into area, that is called the lift. So lift is equal to this pressure into surface area, and in this way lift is generated. And this lift has to counter the weight of the aircraft. That is the intention for this producing aircraft lift. So there are different theories. Another theory says that due to this upper side there is circulation, and this circulation, due to this circulation, the lift is produced. Okay, so we can say that lift is equal to half rho v square s cl. V is the velocity of this infinity, s is the area, rho is the air density, and this is the coefficient of lift which is obtained through the experiments. So this is the about the airfoil lift. Now we will discuss about the drag. So these two forces, that is lift and drag, both are the aerodynamic forces. These forces are acting in the aircraft and they are always acting at the center of pressure, or we can say aerodynamic center. So drag is the force that resists moment of an aircraft through the air. Types of drag, we have parasitic drag and the induced drag. So I have discussed that CD is equal to CD naught plus KCL square. So this is your parasite drag, and this is the induced drag. Okay, so parasite drag and the induced drag, we have two types. The first is called the parasite because it is no way function to aid flight. So it is not, this is not related anyway to the flight. While the second one, it is called induced drag, is a result of an airfoil developing lift. So this is due to induced drag because it is due to the lift generation. As you increase the lift, your drag will also increase. So here we have define the thrust. So if you see that here, if I make the aircraft, this is the thrust which will counter the drag. This is the lift which will counter the weight. So if you see here, in this wing, it will, due to its parasitic drag, it is happening due to the friction, due to the size, due to the interference of this wing and fuselage and other component. This is called the CD naught when lift is not produced. Another one is the CL, KCL square, that is called induced drag. This induced drag is due to the generation of the lift, and due to this lift is generated, and also proportionate the thrust is also generated. To counter this drag is in this direction. We need a force which is in this direction where it will try to pull the aircraft. That is called the thrust. So thrust is the force that propels a flying machine in the direction of the motion. So it is thrust is a propelling force. So this is a propelling force. Define aerodynamic center. So we have just seen that if this is the aerofoil, upper side it will be, this is the pressure, below side it is like this. All this pressure will act in a point. That point is independent of the angle of attack. Whatever angle of attack, this will not change. This is called AC, or the aerodynamic center. So here we will have lift, here we will have drag, and there will be a moment that is called CMAC of the wing. So we can see here that the resultant or of the pressure forces also causes a moment on the airfoil. As the angle of attack increases, the pitching moment at a point, however, the pitching moment remains constant at a particular point, which is called the aerodynamic center. So in this, as per this, aerodynamic center is the point at which pitching moment will remain constant at any angle of attack. Now, propulsive force, just now I have discussed. The force which act opposite to the drag and pull the aircraft and give the motion. So, if it is like this, aircraft is moving, there will be a drag. To counter this side drag, we need a force in this direction. That force is called the propulsive force. Define minimum drag speed. So, if you draw here TR versus velocity, this is the TR. So, there is a minimum drag here. This is the minimum drag, and this is the velocity. This is the V for minimum drag. So, the velocity at which you have the minimum thrust required or minimum drag, that is called the velocity for a minimum drag. We can see that minimum drag speed for level flight is equal to weight, and so the required lift at the various air speed should be constant. The speed at which drag occurs the same as the point at which L by D, maximum L by D or minimum D by L occurs. So, the point at which you have the maximum L by D, that is the drag, that is the point where you have the minimum drag speed. Define air data computers. We have nowadays, all the aircrafts are equipped with number of computers. These computers are fitted with pitot tube, pitot static tube to measure the altitude, to the velocity, for the air speed, for other so many purposes. These computers are able to handle these all type of data and inform directly on the display to the pilot. So, an air data computer, ADC, is an essential avionic component found in the modern glass cockpit. So, it is modern glass cockpit. This air data computer is very much essential so that pilot can see on the screen and he or she can take the action, and he will know that what is the speed, what is the altitude, and any other things. It is also fed to the autopilot as and when required. Define the pitching moment. So, if this is the aircraft and wind is going like this, and if wind is change the direction like this, so angle of attack will change. This angle of attack will make the lift forces more, and aircraft will pitch up or pitch down. So, it is depend upon the location of the aerodynamic center and the location of the center of gravity. So, I will just discuss this thing. Pitching moment. Suppose this is the aircraft. We have here tail. We have here wing. This is the CG. AC will act always in the here 1/4 of the wing. So, here the lift will act. Here the weight will act. So, if wind is like this, then what will happen? This lift force will be extra. So, delta L will be increased. This delta L will try to make nose up. This will make nose up. So, it is called the pitch up, pitching moment. So, this force into this distance, X, L delta L into X is equal to pitching moment. So I will see that the moment which try to make nose up or down called the pitching moment, and if this CG is ahead, then these are the wings. Here is the CG, lift will be here, this will be nose down. So now define the center of pressure. We have already discussed that center of pressure is the point where the total sum of the pressure field act on a body. In aerospace, this is the point on the airfoil or the wing where the resultant vector of the lift and the drag acts. So if you see this diagram again, so this is the wing, here will be the center of pressure, this is called the CP, this is the lift and this is the drag. So the aerodynamic forces, that is the lift and the drag will act at the center of pressure. So it is called the center of pressure. Now we will discuss about the Mach number, and we know it is the ratio of the speed of the object to the speed of the sound. And if it is m is equal to 1, it is in the supersonic. M is less than 1, it is subsonic. If it is 0.8 to 1.2, then it is a transonic region. A number representing the ratio of the speed of an object to the speed of sound in the surrounding air or the medium in which it is moving. So this is represented by m. If m is 1, it is sonic. M is greater than 1, supersonic. If m is less than 1, subsonic. M is between 0.8 to 1.2, it is a transonic. So these are the ranges of your Mach number. Now specific power. Whenever we have some power per unit mass, we say that it is a specific power. The power to weight ratio, it is called the power to weight ratio. It is called a specific power. Formula for an engine power plant is the power generated by the engine divided by the mass. Per unit mass, how much power your engine is generating, that is called the specific power. For the aircraft, we need more specific power because the weight should be less. If the weight is less, the specific power, it will be always more. That is why we try to use the very innovative materials, new type of material which can be used to produce the high specific power. Wave drag, if we draw here, this is the speed and this is the drag, V and drag. So up to here, in subsonic zone, it is very, very less, it is increasing. But as you reach near to 0.8 Mach, slowly, if it is 1 Mach, it will increase like this. So this is called the wave drag. This zone is wave drag. This is happening due to the formation of the shock waves. So wave drag is a force or a drag that retards the forward motion of an airplane in both supersonic and the transonic flight as a consequence of the formation of the shock wave. So as and when you are going above the critical Mach number, there will be some shock wave will be formed. This shock wave will try to generate the force which is trying to retard the motion of the aircraft. That is called the wave drag. And in the wave drag, a huge amount of drag is increased all of a sudden. In the next lecture, I am going to discuss about define and the terminology of the cruise performance. Then these are the references: Anderson JDGR, Aircraft Performance and Design, International Edition, McGraw Hill's first edition. Iselbai ME, Aircraft Performance, Theory and the Practice, AIA Education Series. Any questions, you are welcome to ask. My email ID is yddwivedhi@gmail.com. Please do like and subscribe my channel. If you face that there is some errors, please do inform me. I will try to correct it. Till then, thank you and goodbye.
Like, share and subscribe. Hit the bell icon for more updates.